Welcome to The Explainer. Today, we are shining a spotlight on a group of elements that, well, they're absolutely essential, but they often don't get the credit they deserve. So let's get right into it. We're talking about the unsung heroes of the periodic table.
Okay, to kick things off, let me ask you a question. What do the hardest natural substance on Earth, the very air we're breathing right now, and the tip of a simple pencil, what could they possibly have in common? They seem like total opposites, right?
Well, the answer is they are all built from non-metals. Yep, that incredibly diverse, surprisingly powerful, and totally crucial family of elements is going to be the star of our show today.
All right, so first things first, let's talk about what makes a nonmetal a nonmetal. We'll figure out where this family lives on chemistry's most famous chart.
You know, if you think of the periodic table as a kind of map of a city, the nonmetals have their own little neighborhood. You'll find them all huddled up there in the upper right corner. And that location, it's not random at all. It's actually the key to understanding their entire chemical personality.
And this really shows you just how different they are from their metallic cousins. I mean, they're practically chemical opposites. Metals, they're usually shiny, solid, great at conducting electricity. Nonmetals, on the other hand, are often gases or kind of brittle solids, and they are terrible conductors. They also have this high electronegativity, which just means they're electron hungry. And that trait, that desire to grab electrons, pretty much dictates everything they do.
Now, inside this non-metal family, there is one undisputed A-list superstar, and that is carbon. It's the ultimate architect, capable of building a truly mind-boggling range of materials. So to really get a handle on carbon's magic, you have to know this word, allotrope. It's a fantastic concept. It just means that the very same element can arrange its atoms in different ways, creating substances with totally different properties. It's the secret to carbon's amazing versatility. And you don't have to look any further than diamond and graphite for proof. I mean, they are both 100% pure carbon, but the way their atoms are arranged creates polar opposites. Diamond's super rigid 3D structure makes it incredibly hard and insulator, but graphite forms these slippery layers, which makes it soft enough to write with, and those same layers actually let it conduct electricity. It's wild. Same element, completely different results.
And the list just keeps going. Carbon is in the charcoal that makes your water clean, the industrial coke that helps make steel, and it even forms these amazing, tiny, molecular soccer balls called fullerenes. It's this incredible adaptability that makes carbon so essential to, well, everything.
But hey, carbon isn't the only hero in this family, not by a long shot. So let's meet the rest of the cast, because each one has its own unique and vital role to play.
First up, we've got the halogens. You can think of them as the really reactive siblings in the family. They are eager to make chemical bonds, and their reactivity follows this really neat trend. Fluorine at the top is the most aggressive of all, and that intensity just cools down as you go down the group to chlorine, bromine, and then iodine.
Then you've got nitrogen. Now, if the halogens are the reactive siblings, nitrogen is kind of the stoic, quiet introvert. And the key to its whole personality is stability. The two nitrogen atoms that make up most of our air are locked together by this incredibly powerful triple bond. This makes the molecules super stable and not very reactive at all, which is actually a very good thing. It dilutes all that oxygen in the air, making it safe for us to breathe.
And speaking of the air we breathe, we can't skip oxygen. But just like carbon, oxygen has a really important allotrope you should know, ozone, or O3. So while the O2 molecule is what we breathe, this O3 version forms a critical layer way up high in the atmosphere. It basically acts as Earth's sunscreen, protecting all life down here from dangerous UV radiation.
Okay, so we've met the elements themselves, but the real power, you could argue, is in what they create. When it comes to chemistry, nonmetals are the undisputed masters of making powerful acids. And this right here shows just a few of the heavy hitters. When nonmetals like nitrogen, sulfur, or the halogens get together with hydrogen and oxygen, they create some of the most important acids in the world. Sulfuric acid, for instance, is so good at ripping water molecules out of things, we call it a dehydrating agent. Nitric acid is a famously strong oxidizer. These are the workhorses of the chemical industry.
So let's pull all these threads together. We've met the main players, we've seen what they can do, but let's get to the bottom line. Why should you care? Why do they matter so much?
The simple truth is, our world is literally built on them. Life itself, your DNA, your proteins, is a scaffold of carbon, nitrogen, and oxygen. The air we breathe, the clean water we drink thanks to chlorine, the fertilizers that grow our food, even the silicon chips that run our entire technological world, It all comes back to nonmetals and their close relatives. They are the absolute foundation of modern life.
Which really just leaves us with one final big question. When you stop and think about it, that they form the basis of our DNA, the air we breathe, the shield in our sky, you kind of have to ask, could it be that these so-called unsung heroes are actually the most important elements of all? It's something to think about. Thanks for joining this explainer.